Hello viewers, welcome to all. Myself Priyanka, working as Assistant Professor in Department of Agriculture Engineering, Nanda Engineering College, Erode. Now we're going to see micro irrigation concepts and its applications. First, what is micro irrigation? It is a frequent application of small quantities of water directly above or below the soil surface, usually as a discrete drops, continuous drops, tiny streams, or micro sprays. We can supply water to the plant instead of soil. Then, origin of micro irrigation systems. These micro irrigation systems originated in Egyptian and Mesopotamian countries during 6000 BC. The first experimental system of this type established in Israel in 1959. Our country had initiated micro irrigation system in 1992. The area under micro irrigation system is 137.8 lakh hectares. The state Andhra Pradesh had highest area under micro irrigation system. Then, comparison of traditional and micro irrigation systems. In traditional irrigation system, we can irrigate the land instead of crops. But in micro irrigation system, we can supply water directly to the root zone. So comparing to traditional method, micro irrigation method is more efficient. Then characteristics of micro irrigation. First one is a controlled application, high soil water potential in root zone, partial soil wetting, maintain dry foliage, use of low water quality, energy efficient, fertigation and chemication, adoption of marginal water, adoption of landscape irrigation, and adoption to protected crops. Then types of micro irrigation. There are two types of micro irrigation. First one is surface and subsurface. In surface micro irrigation system, there are three types. First one is drip irrigation system, then micro jets and micro sprinklers. In drip irrigation system, there are two types based on emitters. First one is online drip system, then inline drip system. First one is a drip irrigation system. It is a technique of slow application of water in the form of discrete continuous drops, tiny streams, or miniature sprays through mechanical devices called trippers or emitters. There are two types. First one is inline, next one is online. In inline drip, the emitters are placed inside the laterals. But in online traps, a button-like emitter is placed above the laterals. Then microjets. These microjets are operating at a pressure of 1 to 2 bars and its flow rates are 35 to 250 liters per hour and its wetting diameter is 3 to 6 meter. The precipitation rate of microjets is 2 to 20 mm per hour. Then micro sprinklers. In this system, small sprinkler-like devices called micro sprinklers can spray water over the soil surface in root zone at a low pressure. Then subsurface drip irrigation system. So it is an advancement over drip irrigation system. So it has defined the application of water below the soil surface through the emitters, with discharge rates generally in the same range as surface drip irrigation. It indicates lateral placements below the soil surface. Then soil wetting under subsurface drip irrigation at different duration of water application. The first picture shows location of laterals. In subsurface drip irrigation system, we can place the laterals at different length. And the second picture shows wetting area of subsurface drip irrigation. So comparing to surface drip irrigation, in subsurface drip irrigation, due to varying length of laterals, the wetting area should be more. Then advantages of surface drip irrigation. First one is reduced evaporation loss. Then precise placement of waters and chemicals. More efficient water and chemical use. Enhanced plant growth, crop yield and quality. Less interference with cultural operations. Reduced damage due to weeds, pests and diseases. Reduced exposure of irrigation equipments to damage. No soil crusting due to irrigation. Outcomes of micro irrigation system. It provides an alternative to farming community. It increases the water use efficiency and yields. The concept of micro irrigation is more crop per drop. It ensures the availability of adequate quantity of water, especially in dryland agriculture. Subsurface drip is expected to give valuable results under dry weather conditions, mitigate the adverse effects of water scarcity, supporting substantially good yields. Then components of micro irrigation system. First is a main line, submain, laterals and emitters. Some other basic components are pump, power unit, black flow prevention device, filters, water distribution system, and some other devices for controlling the volume of water and pressure in the system. So first, water distribution network. In main line, it transport water within the field to submains. Usually main line is made of PVC or high density polyethylene and its diameter is 65 mm with a pressure of 4 to 6 kg per centimeter. And in submains, distribute water eventually to the number of lateral lines. It is made of PVC, high density polyethylene or low density polyethylene. It has a diameter of 32 mm to 75 mm with a pressure rating of 2.5 kg per centimeter. Then laterals. It distributes water uniformly along their length by means of trippers or emitters. It is made of LDPE, that is low density polyethylene, or LLDPE. Generally, pipes have 10, 12 and 16 mm internal diameter and has a thickness of 1 to 3 mm. Then emitters. We already see there is a two types of emitters. One is inline emitters and another is an online emitters. Next, pumps and power units. These are basic components. The type and size of pump can be selected depends upon the amount of water we required and the desired pressure and location of the pump. Then electric power units or internal combustion engines. So used to drive and pumps are equally adaptable. Then filters. In micro irrigation system, filter is a must necessary components because the laterals has two types of emitters we already seen. The holes in the emitters have possibilities of easy to block. So the filters can be used to remove sand and large suspended particles from they enter the distribution network. It can remove most of the plant waste from the sources and some sand particles, dissolved particles also can be removed. But it cannot remove the dissolved minerals, bacteria and algae. There are four types of filters. First one is gravel or media filters, screen filters, centrifugal filters and disc filters. First is the gravel or media filters. It has a gravel or coarse sand layers of different sizes. It can effectively remove the light suspended materials like algae, fine sands, and silt particles. This is a primary filtration of irrigation method, and it can be cleaned by reversing the direction of flow and opening the water drainage valves. Then screen filters. It is installed for final filtration, while a majority of the impurities are filtered by sand filters. So only the minute sand particles and other small impurities can be filtered by these screen filters. So this filters contains screens or of cylindrical and non-corrosive material. It is available in wide varieties and types, and its screen sizes were ranging from 20 to 200 mesh. Then centrifugal filters. Usually centrifugal filters are effective in filtering sand, fine gravels and other high density materials. So water is introduced at the top of the centrifugal filters tangentially. So it creates a circular motion resulting in centrifugal force. So which throws the heavy suspended particles against the wall. So the separated particles are collected in the narrow collecting vessels at the bottom. Then disc filters. Disc filters contain stacks of grooved ring-shaped discs that capture debris. During filtration mode, the discs are pressed together. There is an angle of alignment between two adjacent discs, so resulting in cavities of varying sizes and partly turbulent flow. The size of the grooves determine the filtration grade. Usually, disc filters are available in wide ranges of sizes from 25 to 45 microns. It can be cleaned by back flushing the discs. Next one is a pressure relief valves. These pressure relief valves regulators or bypass arrangements usually installed at a point where the possibilities for excessive high pressure. A bypass arrangement is the simplest and cost effective method to avoid the problems of high pressures instead of using costly pressure relief valves. Next one is a check valves. It is also called as non-return valves. It is used to prevent the unwanted flow reversal. They are used to prevent damaging backflow from the system and to avoid return flow of chemicals and fertilizers from the system into the water source. Then chemication. It is an application of chemicals like any fertilizers, nitrogen fertilizers, phosphorus fertilizers, or any pesticides through irrigation water. Then, merits of micro irrigation systems. First one is a low water delivery rate and pressure, precise placement of water and nutrients, and minimum application, runoff, and deep percolation losses. It improves irrigation control and efficiency, less weed growth, and it improves crop yields and also more crop per unit area. And it has some demerits, that is high initial cost, because in micro irrigation system the investment is more, and it has a problem of clogging and salt accumulation in soil. It is an irrigation for seed germination, not to the entire field, and also have a operational constraints. So finally, conclusion. Due to India's growing population, we can concentrate more on food production. But India faces the constraints in food production is water scarcity due to failure of monsoon, less annual rainfall. So we can use the micro irrigation system to utilize the less water source effectively and produce more crops throughout the year. Thank you.